Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello friends, welcome back to the CRT sessions. In this session, we are going to deal the very important concept, that is IP addressing. Interviewer may ask some questions based on Internet Protocol addressing. What is the necessity of the IP addressing? When you talk about a computer network or a sensor network or wireless network or any sort of network, you say that completely depends upon addressing system. As we know, internet layer especially deals with IP addressing. So without IP addressing, we cannot able to communicate with any other node. That's why, as we know nowadays, we are dealing with client and server structures. That means if a client would like to communicate with a server, then both of the computers supposed to require IP addressing, which may be dynamic requirement or which may be static requirement. So hence, without IP addressing, we cannot able to communicate with other systems. So first of all, whenever a computer would like to communicate with others, first of all, it sends a request. So the request consists of IP addressing. So IP address of a client can able to communicate with IP address of another server. That's why without IP addressing or without a MAC addressing, the computer network not exist. That's why in this session we are trying to focus on IP addressing, because when you talk about the computer network is completely depends upon addressing system. So what is addressing system? Here it looks like. So when you talk about Internet Protocol address, that is the full form of IP addressing. So when you talk about Internet Protocol address, so the internet layer deals with IP address. This is the first point. So how do you know that whether system has got IP address or not? Then simply you use in the command prompt, there is a command called ipconfig. This ipconfig for Windows platforms. If you are using Linux platform, then you supposed to use ifconfig. This is for Unix and Linux platforms. So when you type this command, it will give you the different Ethernets the system consists and the assigned MAC address and assigned IP address you would able to find. You want to see all of them, then there is a command called ipconfig/all. It will give you complete picture of your Ethernet interfaces. It shows you all the Ethernet interfaces you have. Normally clients used to have backside one Ethernet port, which means you have only one LAN card. If you consider laptops, you will be given one Ethernet and you will be given one Wi-Fi port. So likewise, you can able to establish n number of Ethernet interfaces to your system. But you please remember, every Ethernet interface you want to configure, the motherboard is supposed to have that capability to fix the slot. So every Ethernet supposed to configure with IP addressing, and what is the IP address is given to the particular Ethernet interface that you can able to get from a command called ipconfig. Okay friends, now let us see the IP address consists of two different varieties. One is IP version 4, the other one IP version 6. So here V stands for version, 4 is nothing but which is the previous version, and currently we are using it because IPv6 is not yet existed so far, but it is slowly been implemented with the help of operating systems. So operating system first of all has to have the supporting system to provide the support to version 4, or you can say version 6. Now IPv4, as we all know, it is 32-bit addressing. And when you talk about IPv6, it is 128-bit addressing, which indicates this can give you 2 power 32 combinations, and this will give you 2 power 128 combinations. You imagine the biggest addressing system you will get from IP version 6. So why there is a requirement of IPv6? Because of n number of communication devices are rapidly in growth. Sensors are there, CC cams are there, whatnot. Nowadays everything is in the form of communication only. That's why every communication device requires one address. Since the rapid growth in the communication devices and every communication device requires one IP addressing, that's why 32-bit is going to be exhausted. That's why there is a requirement of the modern, that is called 128-bit addressing. So you can have vast number of addresses with the help of IP version 6. And now when you talk about IPv4 version 4, which is 4 octets. When you talk about 4 octets, each octet can give you 2 raised to 8 combinations. So this is how we get 2 power 32-bit addressing. So here what is going to happen, this can give you 2 raised to 8, which means 256. This can give you 2 raised to 8, which means 256. This can give you 2 raised to 8, which means 256. This raised to 2 raised to 8, that is 256. That means every octet is responsible to consist of minimum and maximum IP addressing. So what is the minimum addressing? The minimum addressing start with 0 and with 255. So here also start with 0 and with 255. Here also start with 0 and with 255. Here also start with 0 and with 255. So what is the minimum address you feel? It is zeros. What is the maximum address is 255 and 255 every octet, and 255 and 255. So this is the addressing system representation of IP version 4. Well friends, just copy this. We will deal and discuss in detail. Yeah. Well, friends, now let us discuss about IPv4 in detail. So, as I told you, minimum and maximum address is 00 and 00, and maximum is 255, 255, 255, and 255. Now here, the very important question you may ask, IP address representation. So IP address can be represented binary. You can simply say the answer like this: binary and decimal and dotted decimal and hexadecimal. So dotted decimal is a default for IPv4 and hexadecimal is for IPv6. Okay friends, so these are the varieties of representation of your IP addressing. So here I written 0.0.0.0. Why? In the sense because I am following dotted notation. So dotted decimal is nothing but you write the decimal numbers and those octets are being separated using dots. So if I am saying like this, for example, the given IP address is 172.16.0.1 and those octets are supposed to be separated by dotted because operating system supports dotted decimal addressing only. You want to write decimal, I can write decimal. This is a dotted decimal notation. You want to write decimal, simply 172.16.0.1. This is the decimal representation. You want to write the binary representation, write 172 in binary. How to write 172 in binary? You know, two powered systems, that is 128, 64, 32, 16, 8, 4, 2, 1. Use this notation and try to put it individual octets. So you want to write 16. 16 means this is going to be on and the rest is going to be off, and 0 means all zeros, and 1 means 1 is supposed to be on, and 172 you write in the binary. How to write 172 in binary? So I am writing here 128 is on, 64 is off. So I got right now 128. So 64 is off. Next one 32. 32 is on. This becomes how much? 160. So still we need. So here 16 means it's supposed to be, if I add 16 there, it becomes 176. So I don't want 32, 16, and of that 16 I want 8. Now it becomes 168. Now I do not want I want 4, so on it. So when you say 4, it becomes how much? 172, and 2, 1, you make them off. This is what is the representation of 172 in binary. And 16 you want, so 128 I don't want, 64 not required, 32 not required, 16 is required, 8, 4, 2, 1 not required. And 0, 0 means no value there, so all zeros. 1 means 128, 64, 32, 16, 8, 4, 2, 1. This is a binary representation. So that means whenever you give an address, that address can be represented in dotted decimal or in decimal or in binary. So this is a scale you have to follow for conversion of binary into decimal and decimal into binary. I have written this octet for 172 in binary, this is for 16 in binary, this is for 0 in binary, and this is for 1 in the binary. Well friends, now let us see what examiner is going to concentrate towards IP addressing. This is how representation is done. Now after that, let us focus into IP assignment. So you can assign IP static, you can assign IP dynamic. So dynamic is done using DHCP protocol. So this can be done manual configuration also. So you're supposed to type the IP address on your own. Okay friends. And the next one is, and the static IP is nothing but fixed, that will not be changed. But dynamic is nothing but it is going to be released after every 3 months or after every 2 months, after 180, 128 days or 180 days. So based on lease period, it means what, the previous IP is going to be discharged and new IP is going to be acquired. De-acquirement and acquirement is done by dynamic every period of time. That's why the dynamic IP address is going to be changed every time. But whenever you talk about the static IP, that is fixed for your system unless and until the connection is broken, or you can say that connection is disconnected or Ethernet cord is being removed. So manual configuration means what? You need to configure that IP to your system by manually typing. In this manual typing is not there. Whenever you connect a LAN wire, automatically an IP is going to be given to you. This is what is the meaning of dynamic, but that is done by using a dynamic host configuration protocol, right? Just a copy of this. Yeah, well friends, so this is how you have to answer to the interview whenever you get the question like how you can able to assign the IP address. Manually you can assign or dynamically you will get, but dynamic IP is going to be changed after every release period, but static IP is going to be fixed. In dynamic you have to renewal the address after every period of time. That's the meaning of dynamic. And now we see about, so immediately he may raise another question, that is classes of IP address. So if I'm saying like this, categories of IPs, I can say categories of IPs two-way. One is a classful, the other one classless. The question which asked belongs to this classful. So what is the meaning of classful and classless? If you talk about classful, so IEEE provided different classes like A, B, C, D, E. And when you talk about the classless, it's not the concept of ABDs, A, B, C, D, E. A system can be given in simple notation, which is not at all feeling that you're under some class of IP addressing. So immediately you will get another question, that is, what are the ranges of each class? When you talk class ranges 0 to 127, 128 to 191, 192 to 223, 224 to 239, and 240 to 255. Well friends, so how come they derived? Which is completely Octet 1. Octet 1 is responsible for identification or deriving the class. How? What I am saying about Octet 1, the Octet 1 carry forwards, I said 0 to 255 combination. This is 0 and all ones means 255. Why all ones is 255? Immediately you have to rectify this. 124 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 255. So octet 1, not only octet 1, every octet is going to have this combination, but ultimately the class of IP addressing depends upon only octet 1. Therefore, here what is going to happen? Octet 1 is responsible to derive or to divide into different classes. So how come it is happening? So if you talk about the class A, what Octet 1 is saying, Octet 1 must start with a binary 0, which means one bit is reserved. So whenever you say that one bit is reserved, so first bit, you talk about an octet like this, start with 0 and with 1. This 0 has to be reserved. So rest of the bits you can use. This is how you have to decide the division of class A. Okay friends, we will continue. Copy this. Yeah, well friends, now let us see how we could able to get 0 to 127. When you talk about class A, I said you take a octet which can able to derive 2 power 8 combinations. The first combination is 0. I said one bit is supposed to be reserved. Okay friends. So 0, 0, 0, 0, assignment of IP address from right towards to left, and 0, 1, 2, 3, 1, 2, 1, 0, and 0, 1, 2, 3, 0, 0, 1, 1. What is the meaning of this? In decimal 0, I am writing. This is a binary combinations, and this is a decimal combination. And decimal 1, and decimal 2, and decimal 3, 0 is reserved. Come to the last 1, 2, 3, 1, 2, 3, 4. This is how much friends? 127. Dot dot. This is how the class A is given from 0 to 127. Okay. So what is an idea? Only this part reserved. Okay. Now let us see useful address in class A. If you look at the first one, that is 0.0.0.0, when you talk like this 0 cannot be used. So octet 1 decimal 0 cannot be used as it is reserved to system. Therefore, I supposed to start from 1. Okay. And the last one, if I am taking 127.0.0.0, so here also octet 1 decimal 127 it cannot be used as it is for localhost or loop back. That's why this cannot be used and this cannot be used as they are system reserved. So you can use from 1 to 126. This is a useful range. Well friends, this is how the class A excludes 0 and 127 from a range of 0 to 127. This and this cannot be used. So you can use only 1 to 126 classes. Okay. Now let us look at into class B. When you talk about the class B addressing, here also octet 1 is playing a very important role for deriving of the classes. Octet 1 must start with a 10 binary. So that means 2 bits are reserved, which indicates you open a big octet 1. I said 1, 2, 3, 4, 5, 6, 7, 8. First combination. 1, 2, 3, 4, 5, 6, 7, 8. Last combination. But I said here, what? You must not start like this. You must not use combination like this. I said every combination supposed to start with 1, 0. And so on. So what is the idea of this? 128 is on because as we know 128, 64, 32, 16, 8, 4, 2, 1. Using that notation 128 is on, remaining are off. And 128 is on and this 1 is on, so it is what? 129. And next 130 and so on. The last one 191. So this combination also supposed to have 1 0 with all ones. Well friends, so therefore 128 to 129 are useful ranges. There are no exemptions in this as like your class A. But class A there are two exemptions. I said 0 is one exemption, 127 is one exemption because 0 cannot be used and 127 cannot be used. Why cannot be used? We will see. What is the meaning of loopback address also we will discuss. Okay, first copy this. Yeah. Well, friends, now let us see about how class C can be derived. So remember the rules, how the class A is being derived from 0 to 127, and how class B is derived from 128 to 191, and how class C is derived, we will see now. So as we know from class C network, the range is given as 128 to 192 to 223. How come it is being derived? So when you once again asking for class C derivation, you please remember Octet 1 rules. Octet 1 must start with 110 binary. So when you talk about 110 binary, which indicates 3 bits reserved. Hence, you take an octet like this and write 8 combinations, and the last one is 8 combination. And I said you must not use like this. If you use like this, it is invalid. Because as it is saying for class C, octet 1 must start with 110. Hence wise, you use the same combination here. 110, 110, and that particular block is reserved. And remaining you can make use of this. It is 192, 110, 0, 0, 0, 0, 1, 193, and so on. The last combination is 223. So when you talk about class D network, the class D network is given 224 to 239. So how come it is? Once again, octet 1 must start with 1110. So here 4 bits are reserved. That is reserved block. So therefore, this is a reserved block, and the rest you can use 0 combination with 1's combination. But this must be reserved. So this indicates 224 and 225 and so on. The last is 239. In the same way, you talk about the class E. So the class E is given with 242, 255. So here octet 1 must start with 1111, which indicates 4 bits reserved. It's also same reservation as like class D. So when you take an octet like this is reserved, and this can be manipulated, and so on. That's it. So therefore, this indicates 240, and at last it goes to 255. This is how you talk about the class C. Okay friends, now we will see about what is an SCT of class A, what is an SCT of B and C and D and E. We will discuss after this slide. Okay, copy. Yeah. Well, friends, now we understood how these classes are being derived with the help of only Octet 1. That's how Octet 1 is so powerful. Now we will see that what are the necessity of these classes. The necessity of these classes is nothing but if it is a small organization, you can use small networks. So if it is a big organization, you have to go for class A. So based on the number of systems you have or number of nodes you have, better choose that kind of addressing only. So if I am saying, for example, in a company, so being a student or an employee in the company, you're supposed to understand what class you're supposed to follow. If you take a bigger class, unnecessarily overhead will be there. That's why you choose a better class based upon the number of nodes an organization has. So in company, there are 100 nodes. So 100 seaters are there which consist of 100 computers. So which class you follow? It's very simple. Being a network admin or a system admin, because IP addressing plays very important role to this kind of jobs like hardware engineers and network admins and system analysts. So they are all having a good grip here, and sometimes Cisco engineers, they are all having good grip on IP addressing. So which class we follow? Question mark. So if I am taking class A for bigger organizations, because it can provide 2 raised to 24 addresses. It's very bigger. So we don't want. We want simply 100 nodes only. So if I am choosing class B, it's also medium size networks. because it can provide 2 power 16 nodes. 2 power 16 means roughly 65, 536 addresses. These many computers you can have in a company, but we need only 100 nodes. That's why I'm choosing the next class, that is class C, because class C can give you at max 256 nodes. Therefore, if you take class C, it's for smaller organizations, as it supports 2 raised to 8 addresses. As we know, 2 raised to 8 is nothing but 256. Therefore, 100 nodes I want, which is less than 256. Therefore, follow class C. This is how you have to decide which class you have to follow. Okay, friends, copy this. Well, friends, so now I hope so now you understood how to choose a class, whether it is A or B or C. So if you are having only 100 systems, if you go for class C unnecessarily, it is carry forwarding some overhead. Therefore, don't choose a bigger classes for smaller organizations. So how? If nodes are less than 256, you go for class C, preferable. If nodes are less than 65, 536 and greater than 256, then better you go for class B. If nodes are greater than 65536, then go for class A. This is how you have to choose classes. Okay, very simple answer to the interviewer. Now, what about class D and what about class E? We don't use them. Class D only for multicasting. We don't use. And class E also we don't use, only for reserved IPs, as they are used by government organizations like military, I.S.Sro, BARC and STL. They will be dedicated this class E. So the D and E cannot be used by us. So we mostly use C and B and A classes. Okay friends. Now you have a doubt how these nodes are being given, 256 and 65536 and 65 2 power. This 256 is nothing but 2 to the power 8. The 65536 is nothing but 2 power 16. And class A can give you 2 power 24. Why these are being derived? That I will show you in this. So now we see host division. As far as class A concerned, if you observe, I said Octet 1, Octet 2, Octet 3 and Octet 4. This is network ID. This is a host ID. Well friends, if I'm talking a class B, in the 4 octets, this and this is network ID and this is host ID. And class C, network ID is increased, therefore host IDs are going to be decreased. How come? And this is called two-way hierarchy. So addressing system comes under into two-way hierarchy and three-way hierarchy. What is a two-way hierarchy? Two-way hierarchy consists of NID and host ID. Okay, what is that? We will see. Well friends, so far we discussed about how the classes are being derived and what is the need of IP addressing, and internet layer is deal with IP addressing. And in the next session we will see about how two-way hierarchy and three-way hierarchy will be implemented. Stay tuned to us. Thank you very much.